Hello, Earth to students. This is Kellum, and now is not the time to zone out. I just got a text from Joey from Laredo. He wants to know how Bohr's model of the atom is like the solar system. Well, Joey, since 400 BC, starting with that dude Aristotle, scientists have tried to learn what matter is made of. I'm sure by now you've heard of Dalton, Thomson, Chadwick, and Rutherford. These guys did a pretty good job in figuring out what's inside an atom. Protons, neutrons, and electrons. Duh. Up to this point, scientists had also figured out charges and sizes of subatomic particles. And that's good too. But even after Rutherford's gold foil experiment in 1911, there still wasn't a good model of an atom's chemical and physical properties. In comes Niels Bohr to shake things up. He and Einstein were like BFFs. Anyway, so Rutherford's model focused on the nucleus. Bohr turned his attention to the elusive electron. Before Bohr came along, folks thought electrons circled the nucleus like an orbiting planet. The flaw with this model is that an electron moving in a circular path would be accelerating. It's a physics thing. An accelerating electron would create a changing magnetic field. This changing magnetic field would carry energy away from the electron, eventually causing it to slow down, allowing it to be pulled into the nucleus. It turns out it's an electrical force and not a gravitational force that holds the electron in orbit. Bohr built his model based on spectroscopic observations. What the what? Let's break it down. Spectroscopics like to play around with light and shoot it at stuff. When electrons absorb energy, or light, they become excited and can jump to higher energy levels. When that energy is released, the electrons fall back down to the original energy levels, giving off light, creating the pretty colorful lines we see here. You are looking at an emission spectrum of hydrogen. Bohr knew that from spectroscopy, atoms could only absorb certain energies or colors of light. Electrons release the same amount of energy that they absorb. So, Joey from Laredo, Bohr's model says that electrons in an atom orbit a nucleus like the planets around the sun. He called each of these orbits, or circles around the nucleus, energy levels. He also said that the energy an electron has is specific, or quantized, meaning electrons can hang out in one energy level or another, but never in between. Bohr gave each of these orbits quantum numbers, with n equals 1 being the smallest, followed by n equals 2, 3, etc. A normal atom, just hanging out, is said to have its electrons in their ground state. This is the lowest energy state. Here's a really cool picture to sum things up. When an electron absorbs just enough energy, it can jump up to a higher energy level. When that electron falls back down, it gives off light. Kinda cool. That crazy little electron jumping around is what causes colorful fireworks we enjoy on the 4th of July. Different elements make different colors from the most prominent emission line. Cool, yeah? But wait, there's more. Bohr also figured out how many electrons can occupy each orbital. This is important because it's an element's electrons that determine the chemical properties of that atom. Electrons farthest from the nucleus are highest in energy, and the electrons closest to the nucleus are low in energy. Each energy level can only hold a certain number of electrons. The first energy level can contain up to 2 electrons and no more. The second energy level can hold a maximum of 8 electrons. The same is true for the third energy level. There are some exceptions to the rule, but the 4th through the 7th energy levels are also listed here. Bohr's model of the atom can be best understood with a diagram. Although Bohr's model doesn't tell the whole story, drawing Bohr diagrams can be really useful in predicting and visualizing bonding. you'll need to know how to draw a Bohr diagram. It's easy, and here are a few tricks. First, determine how many orbitals are in each element. And to do so, just look at the period number. Remember, periods are the horizontal rows on the periodic table. An element's atomic number not only tells you how many protons an atom has, but also the number of electrons. Once you've got the period number and the number of electrons, you're ready to rumble. There are just 3 basic steps for drawing these things. Draw a small circle to represent the atom's nucleus. Look at the period number and draw orbits. Fill in electrons. These are Bohr diagrams. Lots of little solar systems. If you look at the outermost orbitals, you can see how many valence electrons each atom contains and make some predictions about how that element might react. So, Joey from Laredo, I hope that helped answer your question. Hopefully you can see how Bohr's model of the atom is a little bit like the solar system. Well, that's all I got for now, guys. See y'all later.